Hello, hello, hello. 10.4, inscribed angles and polygons. Inscribed angles and polygons. So first of all, what the heck's an inscribed angle? So an inscribed angle is an angle whose vertex is on the circle and whose sides contain chords. It's not chord, it's chords. Contain chords, period. Come on, there. So here's an inscribed angle. Here's an angle right there. The vertex is on the circle. Okay, that vertex is on the circle, and the sides contain chords. So that's a chord. ZY is a chord, and XY is a chord. So this is an inscribed angle. Is this an inscribed angle? Okay, is the vertex on the circle? Here's the vertex. This vertex is the center of the circle. It's not on the circle. That's on the circle. That's on the circle. This is on the circle. That's not on the circle. But that angle right there, the vertex, that vertex is on the circle. So that side's a chord. That's a chord. So this angle right here, angle ZYX, this is an inscribed angle. Okay. Next, an arc that lies between the two segments, rays or lines, is called an intercepted arc. So here's the inscribed angle, this arc ZX, arc XZ or ZX, that right there is an intercepted arc from X to Z. Okay, X to Z, that is an intercepted arc. Bam. Angle XKZ, from X to K to Z, from X to K to Z, that angle right there is a central angle. Angel, what? Angle XYZ, from X to Y to Z, that angle, that's an intercepted angle. Intercepted angle. Intercepted angle. Well, we'll get to that. Next one, a polygon is an inscribed polygon when all of its vertices lie on the circle. So for quadrilateral Z, Y, X, K, are all these points on the circle? That's on the circle, that's on the circle, that's on the circle, that's the center of the circle. So that would not work. It would not work. So this is not an inscribed polygon. What about over here? Over here, boo-boo. Okay, quadrilateral A, B, C, D. Is that on the circle? Yes. That's on the circle, that's on the circle, that's on the circle. So this is called an inscribed polygon. Okay, that's an inscribed polygon. So quadrilateral ZKXY, that's, I don't know what, it's not an inscribed polygon. That is not an inscribed polygon. It's just a polygon. It's not inscribed. Okay. Oh, next we're gonna make sure this goes in your notebooks. This goes in your notebooks right there. 5, 4, 3, 2, 1. Okay. Next, in your books of note, you're going to put in your notebooks this right here. Okay. Theorem 1010, the measure of an inscribed angle theorem. The measure of an inscribed angle is 1/2 the measure of its intercepted arc. What? Here's what it means. Angle 1010, down here. So this right here, whatever this central angle is, let's say, I don't get 100, sure, 100 degrees. That's a central angle because circle C, this is your center. If this is 100 degrees, the intercepted arc is arc FH. This is the intercepted arc right there. This would also be 100 degrees. Okay. The inscribed angle is the angle that's right where this arc is. That angle right there. That right there is the inscribed angle. And this angle, that angle will be half of this. This angle will be half of that arc. Either way, because these are both the same. What's half of 100? 50. Not 50 cents, just 50 degrees. So angle FGH is 50 degrees. Okay. Make sure the Theorem 1010 on page 554, make sure that goes in your notebooks. Next one. Oh, come on, boss. Come on, boss. Is this next one right? Yeah. Move this over. Oh, there we go. Inscribed angles of a circle theorem. Put this in your notes. If two inscribed angles of a circle intercept the same arc, then the angles are congruent. Okay, what does that mean in practice? Okay, so we have, what is that? Okay, right here. So here's a circle. There we go. And boom. Okay, so the inscribing. So here's. Do you want to? Come on, there we go. So I'm going to pick arc WB. The WB. This arc right here. This arc right there. This arc intercepts. This is arc WB. The inscribed angle for that is right there. This angle is half of this. And this angle is also inscribed. It has the same intercepted arc. So this angle is also half of that, which makes this angle and this angle congruent. If I did something like this, this angle, this is still the same intercepted arc. This angle, this inscribed angle will be the same as these. So it doesn't matter, as long as I use these same 2 points in the arc, I can go way over here, boom, boom. This, come on, there we go. That's gonna be the same measure as these. I can pick a point right there. So bada bing, bada bang. This measure is the same. These are all gonna be the same measure because every single one of these inscribed angles has the same arc WB as its intercepted arc. This arc they called subtend. This subtends that inscribed angle, that inscribed angle, that one, that one, that one. You can pick a way over here if you wanted. Zoom, boom. Okay, this measure is the exact same as that one, as that one, as that one, as that one, as that one. If the arc WB is 60 degrees, then each of these would be half of that. If arc WB is 80 degrees, then each one of these angles would be half of that. If WB is 97.2 degrees, then each one of these would be half of that. Okay, bam, there you go. Okay, next one. Flip it over. Got a lot of notes on this one. This is a lot of notes. This goes in your notebooks. Page 556. A polygon is an inscribed polygon when all of its vertices line the circle. I think we already copied that. The next part you don't have yet is the circle that contains the vertices is a circumscribed circle. Be careful how you say that. The circle contains the vertices is a circumscribed circle. So here we go. This polygon is inscribed. The circle is circumscribed about that polygon. Inscribed is inside, circumscribed is outside. Okay? As you circumnavigate the Earth, you're going around the basically equator of the Earth. You're going around, if you draw a slice right through the center of the Earth, that half. You're going basically, it's like going around on the equator. Okay? Next one, 1012, inscribed right triangle theorem. In a right triangle and inscribed, in a right triangle, if a right triangle is inscribed in a circle, then the hypotenuse is the diameter of the circle. Here this right here. Here's circle J. That right there is going to be a diameter. If that's a diameter, this arc is 180 degrees, and this arc is 180 degrees. If that's 180 degrees, hey, look, we have an inscribed angle. That makes that 90. So as long as that's a diameter, any inscribed angle over here is going to be 90. So if I can pick a point right there, ba-boom, boom. That's 180, half of that's 90, that's 90. As long as that's a diameter, that's 90. That's a diameter, so boom, boom, that's 90. This is just something, what we just went over, this one out here. Here's an arc, this inscribed angle. These are all gonna be half of that arc. Well, the reason why it works, because that's a diameter, that's 180 degrees, and half of 180 degrees is 90. That's why these all have to be 90. So this is basically just the same as this. It's just a little bit slightly different. Next one, this is the last one you have, the inscribed quadrilateral theorem. A quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. Opposite angles are going to be supplementary. Always, always, always. So here we have, boom. Here's a quadrilateral that's inscribed in a circle. That means this angle and this angle, these two angles are going to be supplementary. They add up to 180. Here's another set of opposite angles. These two angles will also be supplementary. They're going to add up to 180. Always, always, always. That's what you have to keep in mind. Any quadrilateral you put in here, I don't care what kind of quadrilateral it is. Let's go, and then all 4 points are on the circle. This angle and that angle, there we go. This angle and that angle have to add up to 180. This angle and this angle are opposite. They have to add up to 180. Always, always. Zoom, 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 zoom. These are opposite. These two angles have to add up to 180. These are opposite. These two angles have to add up to 180. Okay? That's how that works. Okay? Boom, there we go. Now let's get into some of the problems. Work this stuff. Question number 3, find the indicated measure. Question number 3, find the measure of angle W. Here's angle W. Angle W is right there. Arc AT at, that arc is 96 degrees. Well, if that's 96 degrees, that's an inscribed angle. So this angle is going to be half of that. What's half of 96? 45, 46, 48? 48 degrees. 48 degrees. The measure of angle W equals 48 degrees. You can also call it angle AWT if you wanted. But in this case, you can get away with just one letter. Okay. Next. Question number 6. It says, find the measure of arc RS. Oh, sorry. This is 6B. Find the measure of angle arc AS. So here's that, this inscribed angle, that vertex is on the circle. So this arc, boom, la bomba, tomba la bomba. This is going to be twice that measure. What's 2 times 61? 122. So if this is 122, that has to be half of this. Yeah, it works. 122 degrees. Question non-B. Non-B. Name the 2 pairs of congruent angles. Okay, so there's going to be 2 pairs of congruent angles. So, oh, look at this. Here's, this intercepted arc, that angle and that angle both share that same intercepted arc, so that means these two angles are congruent. Angle B and angle J are congruent. And then this arc, that angle and that angle, both of these angles, this is the intercepted arc for both of those angles, so these two angles have to be congruent. That means angle L and angle Q are congruent. There's two paintbrushes. Done with 9B. Angle B is congruent to angle J. And then angle L is congruent to angle Q. Boom. And if you want to be more precise, you can say B, angle LBQ is congruent to angle LJQ. And then this one, angle BLJ is congruent to angle BQJ. Boom. Numero 12. Question 12, the instructions say, find the measure of the red arc or angle. Question 12. This is 12B, by the way. I'm making it slightly different. Find the measure of that red arc. We don't even need that. This is 35 degrees. Ba-boom. And we got this. That angle right there, that's an inscribed angle. That's 35 degrees. So that means this arc is twice 35 degrees, which is 70. That arc is 70 degrees. What would this arc be? Let me use, I'll use purple. I think it's purple. What's the measure of that angle? Oh, sorry, arc. If that's 31, that should be bada bing, bada bang, bada boom. All right, turn over. Question 15, instructions say, find the value of each variable. Find the value of each variable. Ow. Ouchie mama. Find the value of each variable. So find the value of A and find the value of B. These are variables. That's a vertex, that's a vertex, that's a vertex, that's a vertex, that's a variable, that's a variable. So find the value of the variables. So, what the heck? Ooh, how many degrees in a circle? We're going to use that in a bit. Arc KL is 110 degrees. Arc LM is 130. Arc MJ, Jordan, is 54 degrees. The only part we don't know is JK. It's not a joke, it's the arc JK. So we know the full circle is going to be 360 degrees. So I take 360 minus 110 minus 130 minus 54, and you get 66. So that's, this arc is 66 degrees. Well, then we're going to use, I'll do A first. This angle is an inscribed angle. That makes this entire intercepted arc, that entire arc is going to be twice this. Do we know the measure of that full angle? Not yet, but we can figure it out. We know it's going to be 54 plus 66. 54 plus 66, so 120. The whole thing is 120. Ow. That whole thing is 120. That means this is half of 120. So 120 is equal to 3A. Is equal to 3 times A. Say A. Divide both sides by 3. And you get A equals 40. So that's 40 degrees. For number 15, find B. Oh, wait, no, I blew that one. No. The entire thing is 120. This is half of that. It's 60. What am I talking about? It's not 120. That's going to be 60. Bad teacher. That's going to be 60 degrees. Now divide both sides by 3. See, even I make mistakes. And A is going to be 20. How could I do that? That's boo-boo! 20. Okay. Von Bees and Bubba. Here's that angle is 4B. We're going to take, this is an inscribed angle. So we need to figure out how to stop those things from falling. That's an inscribed angle. We need to figure out what this arc is from here to here. It's going to be 66 plus 110. 66 plus 110. So 66 plus 110, 176. 176. So from J to K to L, 176. That's 176, which makes this inscribed angle half of that. What's half of 176? 176 divided by 2, 88. So we're going to put, where do we put it over here? Don't find the room. 88. 88 degrees. This whole piece right here is 88 degrees. Equals 4B. Divide both sides by 4. And B equals 22. 22 degrees. There we go. Oh, how did I do that? See, even I make mistakes. Question 21. Question 21. What is the 21 instructions? Question. Oh yeah. All the stuff's in my way. Question 21. It says find the values of x and y. So find the values of x and y. Question, I can put this, there we go. Find the values of x and y. So we know that a full circle is 360. So we're going to do it right over here. 6y plus 6y plus 4x plus 6y plus 4x equals 360. And then this is an inscribed angle. Yes. That's an inscribed angle. This is the intercepted arc. This is twice that angle right there. 6y is equal to twice that. So 6y is equal to 2 times 2x. This is right now an Algebra 1 problem from here on out. Simultaneous equations, 2 equations, 2 unknowns. I see y, 1, 2, 3, 4, 5. No, we don't have 5 variables. We have 2 different types of variables. We have an x. I don't care how many times I see an x. There's one value of x, and there's one variable that's an x and one variable that's a y. I don't care how many y's there are. There's only a variable of a y and a variable of x. So 2 variables, 2 equations. So we can solve this. Takes the top equation, and we're going to simplify that. So that's 12y plus 4x equals 360. This bottom one is 4x, 6y equals 4x. Here are my 2 equations. Okay, now, oh, I'm going to substitute. Instead of 4x right there, what can I put in place of 4x? Hey, 4x equals that. So 12y plus, instead of 4x goes right there, but instead of 4x, instead of putting 4x there, what can I put in place of 4x? I can put that, because that's the same thing as 4x. Now I have one equation, and there's only one unknown. I don't care how many y's there are, there's only one unknown, it's the letter y. Because we can combine those to get 18, y equals 360. Divide both sides by 18. And we get y equals 20. Y is 20. So we need to find x and y. X, y is 20 degrees. Okay. And next we have, if y, let's go back to here. If y is 20, where is it on the frame? It's on the frame. Here it's on the frame. If y is 20, we can go back and solve for x. 6y equals 4x. 6y equals 4x. If y is 20, 6 times 20 is 120. Now we can solve for x. X is here, 4 is over there. We need to get 4 to the other side. Divide both sides by 4. X equals 30 degrees. Are we done? For 21, find the values of x and y, got it. Then find the measures of the interior angles of the polygon. Oh, okay. You have to find the measure of each angle. So that angle, that angle, that angle, and that angle. X is 30, so 2 times 30 is 60. So we have a 60-degree angle, that's 60. 60 degrees. How do we figure out what that is? Well, all right, that's an inscribed angle. This is the intercepted arc. If x is 30, we know x is 30 from right there. X is 30, 4 times 30. 4 times 30 is 120. If this is 120, that has to be half of that. Half of 120 is 60, which means this is 60 degrees. And these 3 angles have to add up to 180. So 60 plus 60 plus what is 180? 60. So there we go. Question 21, bin! All right, and then to finish it up, question 25 through 30. Determine whether a quadrilateral of the given type can always be inscribed inside a circle. Explain your reasoning. Okay. Determine whether a quadrilateral of the given type can always be inscribed in a circle. So one thing you have to understand is that any quadrilateral that's inscribed in a circle, what's special about that? What's special about these opposite angles? Opposite angles will always be supplementary. No matter, I don't care what kind of quadrilateral that is, but these 2 angles will always add up to 180. These opposite angles will always add up to 180. So same thing here. These 2 will always add up to 180. These 2 will always add up to 180, because this always is going to be true for any kind of inscribed quadrilateral. It's a triangle? No, not necessarily. I don't care. Not a pentagon, not 5 sides, 6 sides, 7 sides, 50 sides. Only for a quadrilateral. If it has a quadrilateral, then the opposite sides, opposite angles will always be supplementary. So that's what you have to think of when you, will it work for a square or a rectangle or a parallelogram or kite or rhombus or isosceles trapezoid? Well, if this is always going to be true, if this is always going to be true, then it can work. If it doesn't always work, it won't work. Good luck, guys. Hasta la bye-byes.